This video will cover solving polynomial inequalities. If you watched the last two videos, they were on solving quadratic inequalities. Quadratic inequalities are specifically x squared. These are going to be polynomials of higher degree. The process is the same as what we did before. You're going to solve an equation that's similar to the inequality. So we're going to replace this inequality sign with an equal sign. Then we're going to take the solutions and plot them on a number line. Then we're going to have to do the test points and decide what intervals need to be shaded. And then we write our solution in interval notation. The difference is I gave you a shortcut that works only for quadratic inequalities, not for these polynomial inequalities. So we're going to have to go through the whole long rigmarole to solve these. The good news on this one right here is that it's already factored. We don't have to do any work, really. We are writing it as an equal sign instead of the inequality sign. And because this is this times this equals 0, this is just using our zero products property. I can set each piece equal to 0, which is these. I have already solved those, giving me these three solutions. These are the three numbers that need to go on my number line. Before, with the quadratic inequalities, we only had two numbers on the number line. So we've got these three numbers, and these three numbers have created 1, 2, 3, 4 separate regions that might or might not be shaded. To decide where they get shaded, we need to do the test points. So I need to pick something to the left of -3, like maybe -4. And remember, all you're looking at really is signs. So if you put -4 in here for x, you're looking at -4 minus 1, which is -5. I don't care about the 5. I care that it's negative. -4 plus 3 is -1. -4 minus 4 is -8. And then this times this times this is just a matter of doing a product of those three signs. A negative times a negative times a negative stays negative. Pick a number between -3 and 1. I like to pick 0 because the arithmetic's easy. 0 minus 1 gives me a negative. 0 plus 3 gives me a positive. 0 minus 4 gives me a negative. And a negative times a negative gives me a positive. Something between 1 and 4 would be like 2. So plug 2 in here. 2 minus 1 is 1, which is a positive number. 2 plus 3 is 5, which is a positive number. But 2 minus 4 is -2, so it's a negative. A positive times a negative gives me a negative. Pick a number to the right of 4, like 5. Plug that in. 5 minus 1 is 4, which is positive. 5 plus 3 is 8, which is positive. 5 minus 4 is 1, which is positive. And a product of three positives is still a positive. So we will shade, because we're looking for greater than or equal to, greater than 0 are your positive values. So I look at my bottom row, and wherever there is a positive sign, that's where I'm going to shade. So between here and here gets shaded, and from 4 on down gets shaded. The only other thing to decide on is what kind of symbol at the endpoints themselves. Since this was greater than or equal to, that's what tells me I need to use the square brackets. So this is the graph of my solution to this inequality. What remains is to name the interval notation. So one interval is from -3 to 1 using the square brackets that are on my graph, union with this interval, which is from 4 on down to infinity. Similar problem, it is already factored for us. I've already written it as the equation. All we have to do is take those three pieces and set them equal to 0 and then solve. This is actually a solution. X equals 0. There's nothing to do to solve. These are two simple ones to solve. Add 3, subtract 2. And here's my three numbers that go in the number line. Incidentally, be sure you put them in the number line in the right position. You want to be sure -2 is over here to the left of 0. Don't just automatically put these numbers in the order you see them up here. They've got to go in the number line in the right place. And then it's my test point time. Pick a number to the left of -2, like -3. If you put -3 in for x, obviously that's negative. A -3 in here is -3 minus 3, which is a -6. -3 plus 2 is -1. A negative times a negative times a negative is a negative. -2 to 0, a number between there would be -1. Put -1 in for x, and that's negative. -1 here, -1 minus 3 is -4. -1 plus 2 is a +1. The product of a negative times a positive is a positive. A number between 0 and 3, something like 1. That means this is positive. Put 1 in here. 1 minus 3 is -2. 1 plus 2 is a positive 3. A positive times a positive is a negative. A number to the right of 3, like 4, that's going to be a positive. Put a 4 right here. 4 minus 3 is a positive 1. 4 plus 2 is a positive 6. Multiply those three positives together, and you get a positive. So to decide how to shade, we look up here at the original, which says less than 0. The values that are less than 0 are your negative values. So look at your bottom row, and I have negative here, so this region is going to get shaded. And I have a negative here, which tells me to color between those two numbers. Take a look at the original sign. It was plain old less, so that tells me I'm using the curved parentheses. And those two curved parentheses face each other. Then your interval notation, this going all the way down into negative infinity land means my interval begins at negative infinity and goes up to negative 2, both with curved parentheses. And this interval is from 0 to 3 with the curved parentheses. The problems you have are not always factored already, so this one's not. This was already the inequality. I've changed it to the equation. This is 4 terms. You should remember that when there are 4 terms, to factor 4 terms, you want to think about grouping. So I'm just looking at those two and those two. For the first two, I can take out a GCF of x squared, leaving x plus 7 in the parentheses. For these two, because that is a minus, that's the sign that comes down in the middle. And the only thing I can factor out of here is a 1, but really I'm dividing by negative 1, which is what changes this to x plus 7. You should recall also to complete your factoring by grouping, what's inside the parentheses better be the same. And since it is, I can pull out that x plus 7, and what's left in the other parenthesis is this minus this. But x squared minus 1 is the difference of two squares. It factors into x plus 1, x minus 1, and then times x plus 7. So on this one, we had to do the work to factor it. Finally, we have it as this times this equals 0, which says we can use the zero products property, set them each equal to 0, and solve. Very simple Algebra 1 kind of solving. I've already placed them on the number line, and now we're ready to do our test points. To the left of negative 7 would be like negative 8. Negative 8 plus 1 is a negative value. Negative 8 minus 1 is negative. Negative 8 plus 7 is negative. A negative times a negative times a negative is a negative. Something between negative 7 and negative 1, something like negative 5. Negative 5 plus 1 is negative 4. Negative 5 minus 1 is negative 6. I've in here, negative 5 plus 7 is a positive 2. A negative times a positive is a positive. Between negative 1 and 1, I can choose 0. 0 plus 1 is a positive. 0 minus 1 is a negative. 0 plus 7 is a positive. This product gives me a negative value. A number to the right of 1, something like 2. 2 plus 1 is a positive. 2 minus 1 is a positive. 2 plus 7 is a positive. This product gives me a positive. So my shading, because this is less than, the values that are less than 0 are negative. I look at my bottom row where my negative is here and here. It's plain old less, which means we are using the curved parentheses. And on the next screen, we have our interval notation. This is from negative infinity up to negative 7, and then this is from negative 1 to 1. One more like that. We're going to set it equal to 0. We're going to factor this by grouping. Factor an x squared out of the front, factor a 9 out of there, and we get x minus 1, and this is what we have. The difference is this x squared plus 9 doesn't factor any further, so all I can do here is set them each equal to 0. Set this one equal to 0 and solve, we get x equals 1, which is fine. Here's where we have a little problem. Subtract 9 from both sides, and the only way I could solve this would be to take the square root of both sides. Remember, the square root of a negative is going to produce an imaginary. I can't graph the imaginary. That says this factor right here is not going to be a factor, or it's not going to give us a number on the number line. So we go to the number line setup. All I can put on the number line is 1. I still, though, put both of these factors in the grid, and I still put the product in the grid. So I need to just pick a number over here, pick a number over here, so I don't have to do quite as much arithmetic as some of these others. So a number to the left of 1 would be something like 0. 0 minus 1 is negative. Put a 0 here gives me a positive. A negative times a positive gives me a negative. Something to the right of 1, like 2. 2 minus 1 gives me a positive. Put a 2 here, this will be a positive. A positive times a positive is a positive. Shading wise, this was originally greater than 0. The values that are greater than 0 are your positive values. So on my bottom row, I am shading this way. Greater than 0 is going to be the curved parentheses because it's plain old greater. And your interval notation on this is just from 1 down to infinity, so we have curved parenthesis on 1 and on infinity.